All right, part 3. Derivatives of non-base E exponential and logarithmic functions. So before we get started, okay, we know that the derivative of e to the x is e to the x, and the derivative of ln x is 1 over x. So we're going to expand our ability to take derivatives to just any base, not just e, okay, and any log, not just lns. Okay, so recall from earlier this unit in section 2, parts 1 and 2, we ended up with this crazy limit we couldn't solve. Okay, so this limit as h approaches 0 of b to the h minus 1 over h. Eventually, we were able to show that the limit as h approaches 0, okay, equals 1, and that worked for e to the x. That gave us our first derivative formula, the e to the x equals e to the x. Okay, but what about all other bases that aren't e? Okay, it turns out through some really heavy algebra that I'm not going to do for you guys, it's beyond the scope. Okay, it works out that this limit, b to the h minus 1 over h, is just equal to ln b. Okay, so that just simplifies the derivative process. So the derivative of b to the x is just b to the x ln b. Okay, that's it. That's on your formula sheet. You can just use it now. This new derivative lets us solve the derivative of a basic ln or logarithmic function now with any base. Okay, so this algebra you are required to do or required to know. So if we start with y equals log base b of x, okay, changing forms, that's b to the y equals x, right? The base log solve for exponents, and that just equals the x. Okay, so if I differentiate that, so the derivative of b to the y is just b to the y ln b. Okay, and then you have to take the chain rule, so just y prime, and the derivative of x again is just 1. Okay, so then of course if you divide out, so by ln b, so then y prime or dy dx is equal to 1 over b to the y ln b. Okay, and remember though, we said that b to the y equals x. So the derivative of the log function is just 1 over x ln b. Okay, so the derivative of any base logarithm is simply 1 over x. Okay, and then you have an extra factor of ln b there on the bottom. Also on your formula sheet, and please use it at will. Okay, so examples of these. All right, so first things first. Okay, so f prime of x. So these are just, the chain rule thing still applies. So this is going to be 1 over 3x plus 1 to the 4th. Okay, and then because it's not a ln, it's a log, you have to take the ln of 10. So that's the first part. And then you have to chain rule the brackets part. Okay, so that would be 3x plus 1 cubed times 3. Okay, so you have to chain rule the 3x plus 1 as well. Now, interesting things. Okay, 3x plus 1 cubed cancels off with the 3x plus 1 to the 4th, leaving with just a 3x plus 1 on the bottom. And we have this extra factor of 4 times 3, so that's 12 on top. So 3x plus 1 times ln 10. And that is our derivative of this first guy. Okay, b. So if I want y prime here, so the derivative of 2x, x squared is just 2x, so pretty straightforward there. Okay, but now the derivative of 4 to the x is just 1 over 4 to the x. Well, I'm thinking of the long one. Okay, this one is, pardon me, so 2x, and the derivative of 4 to the x is just 4 to the x, and then ln 4. Okay, sorry, whew, just about messed that one up. Okay, c, so we're back to logs again. So log base 5 of 3x minus 8. So this is f prime of x, so 1 over 3x minus 8 ln 5. Okay, and then we have to chain rule the 3x minus 8 part. So the derivative of 3x minus 8 is just 3. And so then we'll combine the tops here and get 3 over 3x minus 8 ln 5. So that's our derivative of this one. Okay, d. Ooh, that's a tricky exponent. Okay, so remember the derivative of this is just the same thing. So 2x squared minus x. Then we have an extra ln of the base, so ln 2. Now we have to take the chain rule of the exponent, so the x squared minus x. So the derivative of that is 2x minus 1. So that is the extra piece there. If we really want, we can do some rearranging. So 2x minus 1 times 2x squared minus x times ln 2. So that's our derivative of d. Okay, for e, e is a quotient rule. Not a big deal. So the quotient rule is the bottom times the derivative of the top. Well, the derivative of 2 is just nothing. Okay, and then the derivative of log base 2 of x is 1 over x ln 2. Okay, there's no chain rule for that part. Okay, so bottom derivative of the top minus the top times the derivative of the bottom, which is just 3, all divided by the bottom squared. So that's 3x squared. Okay, if we do some rearranging, first things first, you'll notice there is a 3 that's common to both parts. And oh, look, the 1 over x and this x, hey, those just cancel. Okay, so the 3 factored out, the x is canceled, so all that's left on this first part's a ln 2. Okay, minus 2 plus log base 2 of x. Okay, all over, well, 3x squared is just 9x squared. So the 3 and the 9 reduce. So there's just now a 3x squared on the bottom. Okay, and then on the top, let's see, we get a ln 2 minus 2 minus log base 2 of x. So there is our derivative for that one. Okay, number 2. Find the equation of the tangent line at the given point. So there's a couple of them here. So y prime for this guy. So 10 to the x. So that is just 10 to the x again, ln 10. Okay, so we just take the extra ln of the base. Okay, so remember that is the slope of the tangent line. So let's see, at x equals 1, the slope at 1 equals 10 to the 1, ln 10. Okay, good enough. And so then we have y minus 10 equals 10 ln 10 x minus 1. Okay, and there you have the slope of your tangent line. Okay, just for the fun of it, 10 ln 10, that's pretty close to 23. So just to give you some kind of idea here, so this tangent line has a slope of 23 and goes through the point 110. Crazy. Okay, again, prefer you to have the exact value, so just leave it like that, but I just wanted to show you just how big that was. Okay, and then the last one of these anyways. Okay, so f prime of x. Okay, so that's a log. So this one here, alright, so we take the log, so that is going to be 1 over 3x plus 1, and then ln 4. Okay, so that's the derivative part. Now we also have to take the chain rule of the 3x minus 1, so that's just 3. Okay, so our slope is 3 over 3x plus 1 ln 4. Okay, again, we'll leave it like that, but just for the fun of it, that's about 0. Whoops, pardon me. Okay, that is the slope of that's the equation for the slope of the tangent line. We want the slope at x equals 5. So that is 3 over, okay, 3 times 5 is 15. 15 plus 1 is 16, so 16 ln 4. Okay, so that's the slope, and we're going to leave it at that. But just for the fun of it, that's about 0.14. So our equation is y minus 2 equals 3 over 16 ln 4 x minus 5. So that is the equation of the tangent line. Just for the fun of it, let's put that down, x minus 5. Okay, so that has a slope of roughly 0.14. Okay, so that is how to figure out the slopes with tangent lines. Number 3, use implicit differentiation to find y prime for ln x plus y equals y minus 1. Alright, so first things first, we take the derivative of ln x plus y, so that's just x plus y. Then we have to chain rule the x plus y part. So the derivative of x is just 1, and the derivative of y is just y prime. Okay, equals. Okay, so then the derivative of y is y prime, the derivative of 1 is 0, so we're done that part. Okay, so coming up from here, this part will just distribute. Okay, so you end up with 1 over x plus y prime over x plus y equals y prime. Now remember, this was way back in Unit 3. We did implicit differentiation, so the two y primes we want on the same side. Okay, so y prime minus y prime over x plus y. Okay, so you factor out the y prime, and you get 1 minus 1 over x plus y. Now, you can't just divide that over because you have the 1 minus the x plus y. So remember, how do we divide fractions? Well, subtract fractions. In order to subtract fractions, we have to have the common denominator. So this is going to be, the 1 is going to be x plus y over x plus y minus 1 over x plus y. Okay, so really this just works out to y prime x plus y minus 1 over x plus y. Now that we've made that into one fraction or one number, now I can divide it over. So my y prime is going to equal 1 over x plus y divided by x plus y minus 1 over x plus y. Now, remember, how do you divide fractions? Well, we flip and multiply. So times x plus y over x plus y minus 1. Oh, look, the x plus y's cancel, and your derivative then is 1 over x plus y minus 1. That was a little bit of tricky stuff in the sense that this step here, a lot of kids forget that, but it just comes down to how do you subtract fractions, and it's you have a common denominator and you go from there. Okay, and then number 4, okay, f of x equals x ln x squared, and I want you to find the local max and min values for this function. Okay, so in order to do that, you need to find the critical values, which is when the first derivative is 0. So I guess we need to find the first derivative. So the first derivative here is first times the derivative of the second. So that's going to be 2 ln x times 1 over x, right? Chain rule the ln x part. First derivative of the second plus second, so ln x squared times the derivative of the first, which is just 1. So we really don't have to worry about that. We can if we want. Okay, no big deal. Now, simplifying, oh look, the x and the 1 over x cancel. And you have a ln x in both parts. So ln x, and you have 2 plus ln x. So that's our first derivative. Now to get the critical values, we want that first derivative to equal 0. Okay, so that's when ln x equals 0. Okay, so ln x equals 0. Okay, and you also get when ln x equals negative 2. So in order to solve these, it's easier if we base e to the x equals 0, so then e to the 0 equals x. Well, remember, e to the 0 is just 1, so we have a critical value at x equals 1, and then we'll do the same thing here, e to the x equals negative 2, so e to the negative 2 equals x, okay, which of course is just 1 over e squared. Okay, so those are our critical values. So let's figure out our potential maximums and minimums here. Okay, so that goes back up to the original function. So we go f. Okay, so 1 over e squared, just for the fun of it, I did put that in. That is roughly 0.14, just to give us an idea. So that is the first one, so f of 1 over e squared. Okay, so when you times that in to the original function, that's this guy, right, over here. Okay, so 1 over e squared times ln e, put the negative 2 back in there, ln negative 2 squared. Well, remember, that just pops down in front, so ln e just cancels, so this is 1 over e to the negative 2, 1 over e squared times negative 2 squared, so this is just 4 e to the negative 2. Okay, so that is that guy's coordinate. It's also the same as 4 over e squared. That's probably a better way to write it. Okay, so that coordinate, I'm going to write it down here. The coordinate is 1 over e squared. That's the x coordinate, and the y coordinate is 4 over e squared. So that's one of our potential maximums, minimums. And then the other one is f of 1. So that's going to be 1 ln 1 squared. Okay. All right. Oops. Ln 1, pardon me. So ln 1 is just 0. Okay. So 0 squared is 0. 0 times 1. So the other point is just x is 1, y is 0. So those are our potential maximums and minimums. Now in order to figure those out proper, so I'm moving my tablet around. Okay, so we are going to do the first derivative test for our critical values. Now remember, even though we divided by the x, there's still an x there, which means that x is not allowed to equal 0. Okay, we have a critical value at 0.14 or 1 over e squared. 1 over e squared. And we also have a value at 1. Okay, so those are the regions we have to check. So let's see, that's 0.14. So if we try f prime of 0.1, that'll do. Okay, then we're going to try f prime of, I don't know, let's try 0.5. That'll get that middle region. And f prime of positive 2 will get that third region. Okay, and remember, we're just putting this into the f prime. We don't really need the number here, but it's not a bad thing. These ones are kind of hard to do in your head, but either way, when I typed in 0.1 into the first derivative equation, I got a positive number. When I typed in 0.5 into the first derivative equation, I got a negative number. And when you type in 2 into that equation, you get a positive number again. Well, that means that this is a region of increase, that's a region of decrease, and this is a region of increase again. Okay, so if we analyze our first point, our 1 over e squared, we go from a region of increase, flat, and then a region of decrease. So this one is a max. Okay, and then this one goes from an increase, flat, or sorry, pardon me, decrease, flat, and then increase. So 1, 0 is a minimum point. Okay, awesome. And then part B here, find the points of inflection of this function. Well, remember, the points of inflection happen when the second derivative equals 0. Wow, so that means I need to take the derivative. So if f prime of x was ln x 2 plus ln x, okay, so if that's the first derivative, then we're going to take the second derivative of that. Okay, so this is a product rule, so it is first derivative of the second. The derivative of 2 is 0, then ln x is just 1 over x, plus the second derivative of the first, which is just 1 over x again. Okay, great. So there is a common factor of 1 over x here. So this is now ln x plus 2 plus ln x. Okay, well, oh, look, there's 2 ln x's, so this is 1 over x, 2 ln x plus 2, and we can write that like this. So 2 ln x plus 2 over x. Okay, so that is our second derivative, and we want that to equal 0. Okay. Well, remember that x comes up, doesn't matter. Okay, so then 0 equals 2 ln x plus 2. So we can factor out the 2 ln x plus 1. So really we get our second derivative equals 0 when ln x equals negative 1. Okay, so of course that's base e of x is negative 1. So that is e to the negative 1 equals x. Okay, so that is the x coordinate of our point of inflection. So then we need the original function evaluated at e to the negative 1. Okay, so the original function, I'm going to scroll up a little bit more to get that. So that is x ln x squared. So this is e to the negative 1 over ln e to the negative 1 squared. Well, remember, a ln e just cancels, so that part is just negative 1. Negative 1 squared is positive 1, so that is just e to the negative 1 times 1, or just 1 over e. Okay, so this point is 1 over e, because e to the negative 1 is 1 over e, so that's the x-coordinate. The y-coordinate is also 1 over e, so that is a point of inflection. Okay, and that is it for this part. Call me if you need anything.